So in this video, I'm going to go over this organic chemistry synthesis problem where this is the reactant molecule and this is the product molecule. The very first thing I like to do for synthesis problems is look at the similarities and differences between the reactant molecule and product molecule. So we see that this benzene group and this alkene group is going to be the same exact benzene and alkene group right here. Where we see the new group that we add is going to be this right here, right? And because we see that there is a new carbon-carbon bond, then we know that we're gonna do some sort of nucleophile-electrophile attack, right? And we see this is a cis alkene right here, right? And we can say that this alkene came a alkyne, right? Making an alkynyl anion and attacking this carbon here, where this carbonyl, the carbon at the bond oxygen, could have came from an alcohol, right? So let's draw that out. The benzene here stays the same. This carbonyl could have came from the alcohol right there. This is retrosynthesis technique, right? Where we can oxidize this alcohol to this alkene using PCC, right? You could use Jones as well. And then we could say that this right here came from an alkyne. So we could go backwards even further and say that cis alkene came from an alkyne like this, and alcohol here, and then this isopropyl group over here, where to selectively reduce this alkyne into the cis alkene, we can use H2 with the poison Lindlar's catalyst. Right? And then from here, we can say that this carbon here could have been a nucleophile, this could have been the electrophile, making this the new bond right here. And we can say that this alcohol came from a carbonyl. So when we go backwards right here, right, we can say that that alkyne could have came from an alkynyl anion like this. And then the first step here, this purple dot right here could have been the carbonyl carbon, where the alcohol came from a carbonyl like that. This could have been the isopropyl. This could have been the hydrogen. And the second step, we could do acid breakup with H3O plus to protonate the alkoxide ion to this neutral alcohol right here, right? Now to get to this alkynyl anion here, we can do double elimination. But first, we gotta introduce two good leaving groups to this alkene, which we could do by Br2 and then a product CCl4 solvent, which will give us this halogenated alkene right here, right? And then from here, we could go straight to this alkynyl anion using two elimination reactions, and then followed up by an acid-base reaction, deprotonating the terminal alkyne to give us this alkynyl anion here, where this is the nucleophile, using a strong base like NH2 minus, right? So we use NaNH2, 3 equivalents of it, right? The first two equivalents would do E2 2 times. The third equivalent would deprotonate the terminal alkyne into this alkynyl anion, right? So just to summarize everything for the synthesis problem, we did halogenation in the first step, and then we did double E2 plus acid base reaction to get the alkynyl anion. And then we did nucleophile electrophile reaction, where this is the nucleophile, this is the electrophile. And then we did selective reduction here, right? And then we did oxidation here, right? So this synthesis had 1, 2, 3, 4, 5 reactions, right? So I hope this helps, and let me know in the comments if you have any questions.